So, good morning students. Welcome to Design and Detailing of the RC Structural Elements lab. So, in this session will be the detailing of the portal frame. Now, before I go into the detailing of portal frame, so I would like to tell you that the detailing of portal frame, it is a combination of the detailing of the beam as well as detailing of the column. So by combining the detailing of the beam as well as the detailing of the column, you have to show me the detailing of the portal frame. Now here also, similar to your previous experiments, so we have considered one problem, and after calculating all the dimension of the structural elements, that is dimension of the beam, before that we calculate what are the loads coming on the beam. From the loads we calculate what are the moments coming on the beam. After calculating the moments, we calculate dimension of the beam. From the dimension of the beam, we calculate area of the steel, then we calculate reinforcement details. Similarly, we calculate loads on the column. From the column, we calculate the dimension of column, then we calculate reinforcement detail. So those things we are going to club together and we will be writing the portal frame reinforcement details. And I have taken on problem and I have done all these things. I am directly going to explain you the detailing of those particular portal frame. And when you are mentioning the detailing of those particular portal frame, I am not going to show you the detailing of footing. So when it comes to portal frame, it is just a detailing of beam as well as column. And it is a single bay portal frame. Right. So now we question now. According to the question, it is a single bay fixed portal frame having an effective span 6.6 meter and an effective height 4 meter. Consider a live load of 1.5 kN per meter square on the slab. Design the continuous slab and portal frame considering M20 grade of concrete and Fe4 and 5 grade of steel. Safe bearing capacity of the soil has been given 120 kN per meter square. So now designing part I am not going to do it in detail. I'll just explaining you briefly. So what should be the design steps? The first is load calculation. In load calculation, the first you have to do the design the dead load of the slab, that is self weight of the slab has to be considered. So once you calculate self weight of the slab, then you have to consider the live load of the slab, that is already given as 1.5 kN per meter square, and you can calculate dead load of the slab using grade of concrete. Then after that what you have to do, you have to calculate load coming to the beam from the slab. By considering the triangular variation of the load, so if you consider a beam, so the loads will be coming from both the side of the column if you have considered the middle beam. But if you have considered the extreme beams, then the load will be coming from only one side of the beam. That point should keep it in mind. By considering the triangular variation, you have to calculate what are the loads coming on the beam. Then along with that, you have to calculate the dead load of the beam. So once you know all these loads, you have to add all the loads, will give you the total working load. Once you multiply that by the factor of safety, will give you the ultimate load which is acting on the portal frame. So once you get that ultimate load, which will be in the form of uniformly distributed load, what you have to do is you have to calculate the moments. That means you have to analyze the portal frame by considering the one bay portal frame, that is having one beam and two columns, by considering the column as fixed at the base. So you can do the analysis using various analysis methods like moment distribution method, Cannis method, stiffness method, flexibility method, then moment area method. There are various methods to analyze the portal frame. You can use any one of the methods and you can calculate the bending moments as well as the shear force at the beams and columns. So once you calculate the bending moments and shear force at beams and columns, then we will go for the design of beams. That is your third step. In the design of beams, what we are going to do is, there by knowing the moments which is coming on the beam, we calculate the dimension of the beam, that is breadth as well as depth. Right, if if we have already assumed in the beginning, then by calculating the moments, we finalize what are the whether the depth and breadth that what we have considered is safer or not. That is, check for the depth will be done at the design of beams. Then finally we finalize the breadth and depth of the beam. So once we do that, then if you write the bending moment and shear force diagram of the portal frame, will be having again similar to your continuous beam, will be having the positive bending moment as well as the negative bending moment. The positive bending moment will be at the midspan, whereas the negative bending moment will be at the support. So we will calculate the positive steel as well as negative steel. Here the negative steel is 3 bar of 16 mm and 2 bar of 12 mm. It is 3 bar of 16 and 2 bar of 12. Whereas positive steel is 6 bar of 20 mm diameter. And since it is the beam, you have to calculate the spacing of the stirrups. It is an 8 mm two-legged stirrups at 300 mm center to center. And based on the condition for the spacing, so you have to calculate whether the spacing is more than 0.75 times the effective depth or 300 mm. Right, and you have to provide more spacing at the midspan and closer spacing or less spacing at the support, since at the support the shear is maximum. After that, what you have to do, you have to calculate the column. So by considering the loads coming on the column, you have to design the column. Once you design the column, you will be getting the dimension, and to design the column you can use the SP16 charts, and from that you can design the column. Once you design the column, again you have to calculate the area of the compression steel. So once you calculate that, you have to calculate the reinforcement detail. So from that we calculate 4 number of 25 mm diameter bar has to be provided at the corner, since it is a rectangle, and 8 number of 20 mm diameter at the remaining portions. So that if you calculate total area of the steel, it should be almost matching with the area of steel what you have calculated. Then you have to provide the lateral ties. So by calculating the lateral ties, finally we decided we have to provide 8 mm dia lateral ties at 175 mm center to center. And you should have to check it whether it is the value is coming within the limit, that is the least lateral dimension or 300 mm or the 16 times dia. If it is within that, then the spacing is also over. Once you have all this data, you have to start doing detailing of the portal. If I consider this is my beam. So the total depth of the beam that what I am going to get is 550 mm, and the breadth has already calculated, and the total span is 6600 and the total height is 4000. This is my slab of thickness 330 and this is 160, but we are not showing any detailing of slabs, only we will be showing of the columns. So now from that we have calculated, I told you, since it is a longitudinal section, we are providing 4 number of 25 mm diameter at the corners, right? So therefore you will be having 4 number of 25 mm diameters at corner, but we will be providing only 2 bars, right? Means when you are doing the longitudinal section, you can see 2 bars of 25 mm diameter, and the remaining is 8 bar of 16 mm diameter. So this is the column reinforcement, 8 bar of 16. Then what about the lateral stirrups? It is 8 mm at 250 mm center to center. This is 8 mm at 250 mm center to center. Now we will go to the detailing of beams. So when we are doing detailing of beams, I told you here we have a positive bending moment as well as negative bending moment. Now this is the reinforcement which is provided at the bottom is my positive bending moment, this one. So what is that value? It is 4 bar of 16, right? So this out of 4, this 4 bar of 16 is the total positive bending moment which is provided at the bottom of the beam. But since the moment is very less at the supports, we are not going to provide all the 4 bar of 16 mm dia throughout the length of the beam. We are going to curtail it. So when we curtail it, so up to a distance of 1650 mm from the center of the support, So up to that distance we are going to provide all 4 bars of 16 mm diameter. After that, out of 4 bars we are going to curtail the 2 bars. So when we are going to curtail the 2 bars, only 2 bar of 16 mm diameter has been provided, and from the face of the column to a distance equal to the development length LD, you have to provide the extra reinforcement, which is equal to 47 times the dia. Here also from here to here is LD, from here to here it is LD. Similarly, we will go to the negative reinforcement now. So when it comes to the negative reinforcement, I already told the negative reinforcement is provided only at the supports. Whereas anyhow the compression reinforcement or hanger bars has to be provided. So therefore throughout the length of the bar at the top, hanger bars will be provided of 2 bar of 16 mm. That will be provided throughout the length. Whereas the negative reinforcement is provided only at the support. So therefore if you see here it is only hanger bars, that is 2 bar of 16. But here we will be having hanger bars, that is 2 bar of 16, as well as 3 bar of 16 mm diameter, that is the negative reinforcement, which is provided to a distance of 1650 from the face of the column. From the face of the column till here it is a length of 1650 mm. So up to there we are going to provide the negative reinforcement, which is of 3 number of 16 mm. Therefore if I take cross section here, I have only 2 of 16 mm at the top, 4 of 16 mm at the bottom. But if I take section here, I have 3 of 16 as well as 2 of 16. Here it is 4 of, here it is only 2 of 16. Here again from the face of the column till here it is development length LD. Here also from the face of the column till here it is development length LD. So this is how the portal frame, it is a combination of your beam as well as column. So this completes your detailing of the portal frame. Thank you.